Sallie Baliunas is an eminent astrophysicist at the Harvard-Smithsonian and the Mount Wilson Observatory. And through her work at the Marshall Institute and in other ways, she's also one of the most effective troublemakers in the country. So we're very pleased.
Well, it's grand to be back. I have the pleasure today of calling to your attention some new developments in stratospheric ozone change. I have 4 topics to discuss with you. First, a background on the science with updates on the measurement. Second, to remind you about the health impacts. Third, a case study of one of the banned chemicals, namely halon. And 4, the new fashion of linking ozone loss and global warming that Dr. Soon talked about this morning. And I'd also like to publicly acknowledge a great debt to Hugh L. Sasser and Fred Singer, our good colleagues, for their important work in this area. By 2004, the cost to the US economy of banning refrigerants, fire suppressants, and other halogenated hydrocarbons like CFCs and halon should reach $100 billion. These compounds have not been manufactured in the US since December 31st, 1995. Freon 11 and Freon 12 evolved as the major coolants in air conditioning and refrigeration. Halon 1301 is invaluable for fire suppression. The reason given for the manufacture ban and thus the de facto ban in use: the chemicals erode the Earth's ozone layer and lead to catastrophic harm to human health. But science tells us these fears continue to be exaggerated. Now, doing away with CFCs may not have much of an impact on global ozone over most of the world, but it will certainly impact our economy. The $100 billion cost arises from the need to buy new equipment or to retrofit existing equipment ahead of its phase-out schedule, because the replacement chemicals for CFCs do not easily drop in to the standing equipment. So our first topic: what is the scientific basis for the punishment of the US economy and the lives of its citizens? Ozone is made in the stratosphere, which is about 12 to 50 kilometers in altitude, when ultraviolet radiation from the sun breaks apart an oxygen molecule, oxygen 2, into its constituent oxygen atoms. A single oxygen atom then combines with oxygen 2 to form O3, ozone. The chlorine or bromine in the manufactured CFCs or halons is theorized to interfere with this process and over time cause a net erosion of ozone in the upper atmosphere. Over time, that erosion of ozone should allow more and more ultraviolet rays from the sun, and specifically light at wavelengths from about 280 to 320 nanometers, and it's called the UVB spectrum region. More of that light will reach the ground. This light will cause biological damage, including skin cancer. Now, the EPA estimated in 1987 that the ban on the production of CFCs, as introduced by the Montreal Protocol, would save the US $6.4 trillion by the year 2075 in reduced costs associated with skin cancer, mostly by avoiding deaths from melanoma. In 1991, the administrator of the EPA, William Riley, said that ozone decreases were, quote, more serious than we had believed, and that the deaths from skin cancer would double in the next 40 years. Now, the scientific facts indicate otherwise. First, man-made chemicals like CFCs are not dangerously thinning the ozone over most of the world. And second, the type of ultraviolet that would be let through by thinner ozone layer, UVB, is not the prime culprit in melanoma. On 2 counts, the hysteria and the costly regulations are entirely unfounded. Now, let's consider first the state of ozone in the world. We're going to divide stratospheric ozone into 2 situations. The first is the Antarctic Spring, and then the rest of the world. The Antarctic is a special situation where extremely cold conditions prevail in the winter. It is the coldest portion of the stratosphere, and it sits inside something called the polar vortex. The vortex is a condition of winter high-level winds that circle above the Antarctic continent and prevent the isolated and sunless frigid air there from mixing with the warmer air from nearby. When that air cools below minus 78 degrees centigrade, an unusual type of cloud called the polar stratospheric cloud forms. The clouds help then deplete ozone when winter ends and the feeble spring sunlight reaches the area. But with the advent of the warmth of spring, the polar vortex quickly breaks down, the clouds disappear, the nearby warm air moves in, and the ozone is quickly restored back to its original level. In the Antarctic stratosphere, the ozone concentration temporarily thins around October by as much as 50%. It is colloquially and erroneously called the hole, but it isn't a hole. Now, the key new science concerning the Antarctic spring thinning is that meteorological and dynamical effects dominate the development of the cold needed to form these special clouds. And those conditions are unrelated to the amount of chlorine in the stratosphere, except perhaps above a threshold level. For a warm spring stratosphere, no matter how much chlorine there has been, the thinning does not occur. In the last 15 years or so, the stratosphere has often been cool enough for a springtime thinning. We will return to this question of the stratospheric temperatures in a few minutes. The next key question concerns the magnitude of the problem for the rest of the world. A series of satellites called TOMS, the Total Ozone Mapping Satellites, has been recording total ozone since 1979. As a benchmark, let's look at the results from the World Meteorological Organization's periodic assessments called the Scientific Assessment of Ozone Depletion, this from their last in 1998. Now, to determine the global ozone loss from man-made effects, first you have to subtract all the natural changes. That's not what's shown here. What's shown here is the result of that subtraction. Note on that scale, it's the upper chart, that they don't show the measurements as they were taken, but the leftover, the net change on a very neatly enlarged scale to magnify trends of a few percent per decade. But the question of subtracting natural changes is the heart of the debate. It's subject to large systematic errors because the natural effects are large and they vary unpredictably, and some of them are not even known. You can see that, in fact, by looking that the trend here is not robust. If you were to look from the beginning of the record to 1990, you'd see about a 3% per decade erosion. If you look from about 1992 to the end of the record, you see an increase of ozone. Well, that flies in the face of the theory of the idea that the total global ozone over the world is declining. So that just says that the trend analysis hasn't been done properly and the results are not robust, so you really can't determine a trend from this. There's also a problem with looking at the multi-decadal changes from, say, the sun's output. And what the World Meteorological Organization did was show the sunspot record greatly smoothed for the period of the record over two sunspot cycles. Now, the sunspot number shown there on the chart is meant to justify the subtraction of a wave of even amplitude for both of those peaks in the two solar cycles in the record. But bad luck. Every student of the sun knows the sun has decade to century variations. This is the sunspot number going back 400 years, and you can't just subtract an even line. And in fact, the sunspot number is not the best metric to use when dealing with ozone. A better metric is to use the actual measurement of the sun's ultraviolet radiation in the wavelengths that are effective in forming ozone. But the problem is there are no measurements for this that go over decades and are accurate enough. The best one could come up with is composite of a nearby emission line of magnesium, singly ionized magnesium down near 280 nanometers, which is what this compilation is. Notice instead of having two even peaks, there's a small peak and then a larger peak in the same interval over which that trend analysis was done. So in fact here the multi-decadal natural variation of the sun was not subtracted out properly in that chart. Now let's move to the update of the ozone measurements. This is a compilation from 4 different satellites, and we're going to show you not what's been happened after everything has been subtracted and detrended. We're going to show you the actual information. And to compare, well, let's start out with the Antarctic. Yeah, let's start here. The southern hemisphere from minus 70 to minus 75 degrees latitude. This is the region of the ozone hole. And at the start of the record, in the late 1970s, to about 1990 or so, there's a strong decline. This is, again, the Dobson units now, the measurement of the total column density of ozone in milliatmospheres per square centimeter. And there's no adjustments to any of these charts, because, as I mentioned, it's very hard to get these adjustments correct. Now, the following, I'm going to show you all the information just to show you that there's nothing to be hidden here. On this chart, there's a linear trend of a loss of about 9 Dobson units per decade in the early part from 1979 to 1986. But after 1986, there's been no significant trend. There's not been any more growth of the ozone hole in Antarctica. Now, the 1998 World Meteorological Organization report said, the springtime Antarctic hole has continued unabated. Well, yes, but equally one could cheer the news that despite the continued rise in stratospheric chlorine and bromine, because the peak of those chemicals in the peak loading has only just occurred, things got no worse. And that's a clue here to the strong dynamical and meteorological effects that we mentioned earlier that make the cold that's critical for this, not the chlorine. Now we have, oh, you're moving them around for me? Now I wanted the 65 south to 90 south, October to February. This is the springtime. That one was all year round. Just to show you, there's nothing frightening here. 65 degrees south to 90 degrees south, but October through February, so only through the springtime. There is a linear trend of about 9 Dobson units loss initially per year in the record, up to 1986, and then once again, no significant trend since 1987. So the whole ozone hole has not grown despite the increase in chlorine and bromine loading in the stratosphere. Now the entire southern hemisphere, which is from the equator to 65 degrees south, and there's been no significant trend since 1984. Perhaps an earlier very weak trend, but that earlier weak trend averaged over the southern hemisphere measurement here is entirely caused by the high latitude trend that was there. So no modern ozone loss, that is the ozone hole, hasn't grown and swallowed the stratosphere of the southern hemisphere. Now let's move on to the equatorial south. This is from -5 to 0 degrees, and no, there is no significant linear trend. Here there's something interesting. There's a 2 to 3 year oscillation caused by the quasi-biennial oscillation, these winds of the stratosphere that shift direction every 2 or 3 years. Right, that's what that large amplitude is. But within this, there is no significant trend. Okay, the northern tropical band from 0 to 5 degrees north, once again, no significant trend. The quasi-biennial oscillation is quite strong. The northern hemisphere, 0 to 65 degrees north, where most everybody lives, no significant trend whatsoever. By the way, the huge amplitudes yearly are, of course, the seasons, the tilt angle of the sun to the earth. The North Polar region, this is 70 degrees to 75 degrees north. Oh, okay, that's the springtime. No, this is the total year round, 70 degrees north to 75 degrees north, no significant trend. And of course, you may have been reading about the imminent ozone hole over the Arctic. Certainly isn't here. And then just to be fair, to look at the springtime measurements for 65 to 90 degrees north. Again, very strong seasonal cycle. The seasonal cycles are largest at high latitudes. No significant trend. So there's been no ozone loss over the northern hemisphere. And now this is the global. Now global, 65 degrees south to 65 degrees north. Once again, there's no trend since 1985. The decreasing trend prior to 1985 is limited to those that high latitude southern effect. So the total ozone, the summary of all these charts, is that the total ozone decreased only in the high southern latitudes between 1979 and about 1985 or 1986. And there's been no further deterioration since. The chlorine and bromine loading has continued and has just peaked, as I mentioned. Now, over most of the rest of the globe, and especially over the northern hemisphere, there's been no declining trend in stratospheric ozone in the last 20 years. There's been no ozone loss over the last 20 years. The only reason one sees that there is when one tries to make all these subtractions and then is left with some net trend and then calls that the human trend, but that's not the way to do this. Now, an important point though, why look at total ozone concentrations rather than playing the game of making net trends and trying to subtract all the natural effects which one doesn't know? Because what matters for the risk of UVB radiation is the protection offered by the total ozone concentration, not the net trend. So our second topic about the UVB. Recent UVB ground measurements and a reanalysis of earlier data show no increasing trend in surface ultraviolet flux over the United States. That finding is consistent with the Northern Hemisphere record that I just showed you of total ozone in the overlapping period of both sets of data, and that interval is 1979 to 1985. So the fears of adverse health effects of increasing ultraviolet from ozone depletion over the US were and remain unfounded. Now, the ultraviolet fear blossomed from these predictions of excess melanoma deaths. The 3 million excess cancer deaths by the year 2075, earlier mentioned by the EPA, refer to malignant melanoma, a rapidly metastasizing skin cancer that has been increasing ever since the 1930s in incidence, long before the widespread use of CFCs. Epidemiological studies relate that melanoma increased, not explained to long-term UVB exposure radiation. Laboratory studies, in addition, suggest that melanoma is enhanced by longer wavelengths of light, for example, ultraviolet A, or even ordinary blue sunlight, but not UVB. This means that changes in ozone and bans on life-saving chemicals like CFCs and halons can have little impact on the incidence of melanoma. So the whole cost-effectiveness calculation is reduced to naught. Even apart from the question as to whether the ozone is decreasing and the UVB fluxes at ground level are increasing, and they are not, the EPA warning in 1991 on deaths due to melanoma are entirely without foundation. Now, a case study of one of these chemicals, halon. According to the United Nations Environmental Panel 1998 assessment report of the Halons Technical Options Committee, halons exhibit exceptional effectiveness in fire extinguishing and explosion prevention and suppression. They are clean, electrically non-conductive, and leave no residue. Halon 1301 has proved safe for human exposure at concentrations sufficient for fire extinguishing. This unrivaled combination of desirable properties led to the selection of these agents for many fire protection applications. Now, the critical uses of halons allowed by the international agreements almost all apply to Halon 1301, so I'm going to focus on that. The rule is that the needs of the US for Halon 1301 must be met from existing banked supply, that is, whatever we already have. Although there are countries exempted from this, like China, they can and they do manufacture more, although we are not allowed to import them into our bank. Through usage, leakage, and replacement by alternative chemicals, the bank for the US will gradually dry up. The estimated lifetime of the bank is right now 200 years. Now, halon is critical in commercial and military aviation, for example, in engines, cargo bays, lavatory compartments, and the portable fire extinguishers and dry bays. During fuel tank inerting, on the flight line, for aerospace, during payload and vehicle processing, in satellite and vehicle tracking stations, during launch operations, in wind tunnels and spaceflight vehicles. Further military use includes in ground combat vehicle crew compartments, aircraft engine nacelles, and ship machinery spaces. The gas and oil industry, besides merchant shipping, also rely on it. Now, how important is halon to saving lives and property? just as the personnel who served in the Persian Gulf situation. The Chief of Fire Protection of the U.S. Central Command of the Air Force relates some stories. Once a C-135 aircraft came in with an in-flight fire and fire was visible coming out of the pylons. The original fire was controlled with an onboard halon system, but as soon as the plane touched down, the wing caught fire again. We met the aircraft when it stopped and quickly put the fire out with halon. A CBO aircraft at Bahrain blew its tires on touchdown. With the wheels on fire and both wings full of munition, things were pretty hectic, but we were able to put the fires out with halon and another fire agent. In these situations, halon being clean was preferred because downtime for the plane was minimal and it was able to return to combat action quickly. An F-16 with battle damage and fire was coming in at one of the northern bases. The pilot ejected, but the plane came in, touched down, and rolled to a stop intact. The halon system inside must have worked. And the Chief of Fire Protection sums up the miracle of halon thusly: we could not get enough of it. Halon 1301 is uniquely effective and so far seemingly irreplaceable. Now this chart shows how its destructiveness would be in the stratosphere compared to CFCs. Halon contains bromine, the CFC is chlorine, but one can make an equivalence calculation of how much of the halon use would translate into an equivalent erosion of stratospheric ozone by chlorine, or just in this case, the calculation is the amount of chlorine in the stratosphere. The first part of this chart from the 1940s on up to about the year 1994 is measurements, and then the latter part is estimates based on the international treaties. So the peak indeed has occurred 1999, 2000, peak of chlorine. That's chlorine from all the other CFCs. The equivalent amount of chlorine loading of the stratosphere from all the halon is that tiny curve down there, two slightly different calculations. In other words, halon, despite its importance, despite its effectiveness, is a fraction of 1% of the chlorine loading of the stratosphere. The rush to ban halon, which in fact was banned a year before the CFCs, to me makes no sense. Now, I mentioned the halon bank for the US is estimated to be good for roughly 200 years use. That seems a plentiful time for technology to find alternatives and for equipment to turn over. But during the Persian Gulf situation, for example, which lasted just 45 days, the F-16s alone used 17 years of the US halon supply compared to all the other airborne Air Force systems. So I guess we had better ban war as well. Now, the Next Generation Fire Suppression Technology Program is sponsored by the Armed Services, is providing $46 million research money over 8 years to develop, and not install, just develop, new fire suppression technologies for the replacement of halon 1301 in weapon systems. The goal of this program is that an alternative easily retrofittable technology will be demonstrated by the year 2005, but this remains to be done. The strategy document notes, none of the current alternative chemicals offer all the properties of halon 1301. Nearly all of them are substantially less effective and will require additional weight allowance and storage volume. In addition, the use of nearly all of them will result in a post-deployment atmosphere containing appreciable concentrations of acid gas, an atmosphere that is not suitable for human occupancy, and which will chemically attack metals, synthetic materials, and electronics. In 1997, the National Research Council study of halon on behalf of the Navy and the Navy's use of it concluded, it is unlikely that a drop-in replacement agent will be discovered that will exhibit all of the beneficial properties of halon 1301 and not exhibit significant environmental impact. Now, it's that last phrase, significant environmental impact, that's led to a new issue with halon and the CFCs. There's a serious problem plaguing the development of alternatives. They are, in general, strong greenhouse gases. The EPA now considers something called the global warming potential in the approval process for CFC and halon replacements. But this is odd because Congress in the 1990 Clean Air Act and the Senate in the 1997 Byrd-Hagel resolution clearly intended that the Kyoto Protocol limiting carbon dioxide emissions not be implemented. Now, what does that have to do with CFC replacements? Well, by considering the greenhouse warming potential of alternatives compared to the climate impact of carbon dioxide, the regulatory process is actually becoming a de facto implementation of the protocol, of the Kyoto Protocol, which is clearly forbidden by Congress. Now, among the many reasons that the EPA uses to argue that it has regulatory authority despite the intent of Congress is the following from the EPA General Counsel. The Senate insisted that the executive branch not commit the U.S. to binding international legal obligations, that is a treaty obligation, without further advice and consent. That's all right with us, I said. But the Senate's statement on this point has no bearing on the scope of existing domestic legal authority to address pollution problems as a matter of domestic policy, independent of any international legal obligations. In other words, it's a domestic issue, and that's the EPA, no matter what Congress says. Now, the fourth and last topic is this fashion of linking climate change to ozone depletion. There is an observed fact that the stratosphere has been cooling. Willie Soon showed you that this morning from 1979 to the present. And the warm spikes are the two volcano eruptions warming the lower stratosphere. But there's been new interest in unifying both the man-made ozone change and man-made climate change. Now, ozone loss in computer models is predicted to produce a modest lower stratosphere cooling in the climate models. So the ozone loss could now be linked to climate change. Climate models also predict that the concomitant rise in stratospheric CO2 abundance will cool the stratosphere. This in turn might worsen the ozone loss if the stratosphere reaches its threshold temperature of minus 78 degrees centigrade for polar stratospheric clouds to form, although one is a far way away from that anywhere but in the Antarctic. Thus, there might be feedback between ozone loss and climate change from the rise of CO2 concentration in the air. But there's many problems with this kind of notion. The first is the logical error of the false dilemma. That is, there is a third way to cool the lower stratosphere, and Willie Soon also showed you that. That's by raising the water vapor content there. And the indication of that trend really has appeared in observations. So the lower stratosphere water vapor is increasing, and that could be causing cooling, the observed cooling. Now, what is the source of the water vapor increase? No one really knows, but it may be natural. So it means that there are natural changes cooling the stratospheric temperature. Second problem is that the air's temperature record really contradicts these ideas altogether. First, the cooling in the lower stratosphere by water vapor or by carbon dioxide increase, according to these models, must be accompanied by a warming in the troposphere. And I don't have to show you again John Christie's measurements of temperature in the lower troposphere, which show absolutely no net warming trend. Over the last 20 years, this same interval. Now, another overlooked natural factor in influencing stratospheric temperature and ozone trends may be the sun, and even in the polar regions. This is a chart of temperature for the North Polar region, and the sun, the sunspot cycle of the sun, going back to the 1950s. And the top is a chart that doesn't look like there's much correlation because indeed there isn't. The winds at the northern and the phenomenon of the quasi-biennial oscillation, that is the winds that blow in the stratosphere for several years in easterly phase and then reverse direction and blow in a westerly phase, have to be split up here. So in this middle chart, we look only at when the times when the wind's blowing from the west. There's a huge correlation with the sun. So the temperature of the stratosphere, when the winds are blowing from the west, is highly correlated with the sun. When the winds blow from the east, there's not such a good correlation. Right. But this effect has to be accounted for, and has not been, in the analysis of looking at polar stratospheric ozone. There's also a similar kind of correlation for the Antarctic. And finally, another problem is that the stratospheric record is quite complex in temperature. And while this cooling in the last 20 years has got everybody excited, if you look back in time, there's an interval just prior to it where there was cooling, but at less of a slope. And then finally, early in the record, was the strongest cooling of all. Now, early in the record, that certainly can't be from ozone loss and carbon dioxide increase. And that's the strongest trend in cooling altogether. So these notions to link these, I think, are just high fashion that will flitter away when the data are looked at, when the data are considered. So the evidence tells us that ozone changes in the inhabited portions of the world are primarily the result of large natural fluctuations, like changing ultraviolet output of the sun. No surprise, because the sun's ultraviolet controls a lot of the chemical reactions. And also the new results of meteorology, meteorological and dynamical conditions, like the quasi-biennial oscillation or volcanoes. As yet, there is no evidence to suggest a man-made ozone crisis. And there certainly has not been an increase in UVB radiation over most of the world, because there's not been a significant loss in ozone over most of the world. Now, what to make of all this? Richard Benedict, the US negotiator who was instrumental in creating and leading in creating the international agreements for the US in the ban on CFCs and halons, assessed his experience in 1991. He said, "Perhaps the most extraordinary aspect of the treaty was its imposition of substantial short-term economic costs to protect human health and the environment against unproved future dangers, dangers that rested on scientific hypotheses rather than on firm data. Indeed, the trouble with ozone lies not in the stratosphere." Thank you.
Simulating the microphone.
Hang on a second.
Oh, wait, I've got no check here. Thank you. What I'd like to do is make a statement, and I'd like you to critique it. I'd like to find out if I'm right. Okay. Away from the data you've given us, that there has been no change in the ozone since '86 over the poles, and no significant change at the other latitudes since they've been taking data, which I guess is the beginning of the International Geophysical Year.
No change over the South Pole.
Right.
North Pole is unchanged.
Well, right, the rest
North
of the
Pole
latitudes,
and just the South Pole. Right,
yeah,
go ahead.
the only change at all is the South Pole, and that's only prior to '86. Okay, now, we're interested in this because of the UVB hitting the deck. Now, I understand there was a series of instruments all over the U.S. measuring the UVB hitting the surface, but after a while they were no longer maintained. And the results of those is that while they were taking the data, there was no change in the UVB hitting the deck in the United States. And finally,
There was actually
UVB's been actually going down.
there was actually a decline of those
really?
data. Right.
Maybe that's
Decline
why
in surface
maybe
UVB.
that's why they quit maintaining it. No joke.
Well, no joke. It's why Professor Will Happer of Princeton was fired as scientist at the Department of Energy, because he suggested that that kind of program be re-implemented, that is looking at the true human health risk was not, was not useful.
Okay, so the major point is the trend is actually favorable, never mind what the ozone.
Trend was down, although a recent reanalysis of those data suggests that they really don't see a downtrend, but at least no increasing trend. It's consistent with zero as well, so just broaden the uncertainties.
Okay, so
But no health risk.
yeah, that's right. The next point I was going to make is that I understand that in theory, going back to just the theory, that if the ozone hole was going to eat us alive, that the UVB hitting the deck was expected to rise about 10%. Okay, I understand that the same data revealed that the UVB hitting Texas is double what it is Minnesota. And so if it was that big a threat, how come the Texans, not to mention us Hawaii residents, have long since evacuated Hawaii or Texas in panic to get up to North Dakota where we'll be safe?
Well,
I guess I'm okay on that.
you've been reasonable and logical in this. That's the problem. Any potential threat of harm to Mother Earth must be immediately and rapidly mitigated, even if it doesn't exist. And that's called the precautionary principle. And it's antithetical to science is the only way I can describe it. And
if I remember correctly, Peter Beckman said that he agreed that thousands of cases of melanoma were due to CFCs because that was the most efficient method of air conditioning, and the reason that people like me live in Arizona and people live in Florida and Southern California and the Mediterranean littoral, and that's the reason.
yes, it's cultural changes. And in fact, I think a better regulatory policy would be to consider banning bikini sunbathing. Maybe
Wait a minute.
maybe a 14-day waiting period when you go to buy your bikini, informed consent, a licensing procedure by your local health official about the risks of this, and tanning beds ought to be banned. It's really cultural, the increase in melanoma. Mandatory education.
Okay.
And long sentences for violators in darkened cells. They get no sunlight exposure.
As we noted, the concern about ozone and its potential depletion is because it absorbs energy in the UVB band. And the concern about chlorine is because it ostensibly reduces the concentration of ozone in the stratosphere. But if I'm not mistaken, a lot of the other diatomic compounds that you could form with chlorine or oxygen, including O2, hydrogen chloride, etc., all also absorb energy in the ultraviolet band in some portion of it. So has anybody thought about the net effect on absorbing ultraviolet of changing the chemistry, or is that not significant, or it just doesn't come out?
It's probably too complicated to do, and maybe Fred could make a comment on that.
I was actually going to comment on something else if I
Do you want to answer his question? Some of the other chemicals don't absorb at UVB or don't absorb effectively, but it's the change that matters.
There's a very strong absorption from SO2, which has bedeviled people who are trying to measure ozone from the ground. And the reason why UVB partly is absorbed is because there's a lot of scattering in the lower atmosphere, which increases the path length by so much. And almost anything will absorb UVB.
Right.
So let me comment on the UVB first. You're absolutely correct. None of the measurements so far show any increase in UVB that can be relied on. All of the UVB increases that have been reported are calculated based on an assumed depletion of ozone, which is exactly backwards. I might mention that there was a paper published in Science, of all journals, by Jim Kerr and McElroy on claiming, measurements in Toronto, Canada, very amusing, claiming that UVB increased by 35% per year. Just think of this for a moment. Supposing you had a savings account where you increased 35% per year. It didn't take us very long. Pat Michaels and I wrote a comment on it to show that the statistics was completely spurious and that the actual number was 0, not 35%. This was not quite acknowledged, and this paper is still being quoted widely. It's a wrong paper.
Yes, it is.
Eradicated.
It is.
Every other paper that we've examined that claims the UVB increase doesn't stand up. I'd like to also confirm another point Dr. Baliunas made about the ideological nature of this, which is apparent for ALAR, and mention two other sort of amusing examples. One, of course, is methyl bromide. Methyl bromide is an extremely important chemical to agriculturalists and to anyone concerned with food, because it's the only effective fungicide and insecticide and everything else that we have for preserving food and also for growing, particularly in California, growing strawberries and other kinds of specialty crops. The fight to ban methyl bromide, as far as I can tell, is primarily ideological. It hasn't, when you look at it, it really has the slightest impact on stratospheric halons or halides because it has such a short lifetime. Its lifetime is less than 10 years, which means very little, if any, will percolate into the stratosphere. It will all be destroyed. Every year or so, when the lifetime is remeasured, it becomes shorter and shorter. The lifetime being so short means that even if you should make a big mistake, you can always rectify it and it'll disappear. So it's entirely ideological. The Air Force, now I'm changing this up just slightly, to show the ideological nature of it all, has banned a halocarbon used in the Peacekeeper missile. Excuse the name of that missile, which is used because it's our prime ballistic missile carrying nuclear weapons. So the Peacekeeper missile uses halocarbons for some kind of lubrication or something in its wire. I forget what it is exactly. They decided to replace all of these halocarbons at great expense in case during a all-out nuclear war should be some damage to the missile. That's what I've read. Notice that if anybody can verify this and document it, would be, I think, very valuable, because it shows the complete asininity of this whole effort. Another thing I want to mention, since we're talking about asininities, is the EPA. The EPA has testified several times now to the cost benefits of removing halocarbons like CFCs and others. And their cost-benefit analysis, which Dr. Baliunas alluded to, gives benefit costs, health benefits, including mainly skin cancer, of $32 trillion, $32 trillion, and claims a benefit-to-cost ratio of up to 1,000. It's just, it just boggles the imagination. And unfortunately, Congress has never asked them to document this. We've been trying. Remember, we testified together once, and we had Mary Nichols from the EPA, an assistant administrator, testifying to this. And we wish we could have sat on the bench where the congressman sat and asked them, please document this number. We want to have it in writing. Nothing's ever happened. No. One final thing. To amuse you further, it's about frogs. We all love frogs, of course, our web-footed friends and so on. There's a professor at Oregon State University, Blaustein, I think his name is, who keeps coming up with the idea that that amphibians are disappearing because of UVB. Well, since there's no trace of increase in UVB, he was questioned on that by a science reporter from the Washington Post, who has since left the Post, obviously. It doesn't fit into that environment there. And Blaustein's reply was, well, if UVB is increasing, it must be something else. Maybe it's a fungus.
I would like to say three things to Fred. One is very much thanks to him for his comments, and also see his website where he has a lot of wonderful information posted on the ozone loss. He also mentioned the new calculations that are being done in substitute of making UVB measurements. When you listen to your nightly weather report, you might get, or in the newspaper, you might get the daily UVB index. You might think that there's a little meter in a city and somebody's actually measuring that before they report on it. It's a computer program where they put in computerized clouds, computerized haze, computerized water vapor, computerized particles between you, the sun, and you, and then calculate what they think the UVB index ought to be. But it's, when you look at it, realize it's a computational fiction that's being printed there. And the third point was this case that Fred was talking about. I don't know about the in our missile defenses in particular, our missiles in particular. But I did have an interesting quote from engineer, which is the Army Corps of Engineers, and they are talking about the new environmental ethic in the armed services. And they wrote, "A dramatic change is taking place across the country. The beliefs and values of the nation are turning green, not olive drab green, but environmental green. As a logical extension of this ethic, the American people require their Army to protect the increasingly fragile and vulnerable natural environment in training, in operations other than war, and to the extent feasible, in combat." So it wouldn't surprise me if the story you related were true.
Most of us are here due to greater human health issues that we're exposed to. Either greater human health issues through lack of civil defense, greater human health issues through lack of DET, or the restricting of your access to energy through control of carbon dioxide emissions. I was a development engineer for Chrysler Dynamic Chrysler for 10 years, and in reference to the subject R12, R134A, the refrigerant in your vehicle, I was in the AC development group back when we were making those transitions. I can tell you that R134A is less effective than R12. It requires bigger evaporators, bigger condensers. If you have an R12 system that leaks, you just can't replace it with 134A because you're one, going to get diminished efficiency. Two, you have to replace your oil. Two, that new oil, which is called PEG oil, is extremely toxic and it's very reactive with many metals that you might have in your AC system, so you just might have to replumb your whole lines. Now keep in mind, AC systems do leak, they will always leak. If we're talking about greater human health issues and we have an infrastructure within this world that was using the most abundant, inexpensive, efficient refrigerant, and we have now cut the world's production of that refrigerant by some large fraction, and there's no one-to-one replacement. What does that do to our greater human health issues when that population is dependent upon refrigeration for food preservation, medical preservation, etc.?
That's a very good point. It always increases the costs, and those have unintended consequences.
I got the feeling some people are just going to have refrigeration units, or do right now, that are just not functional, and they just lost that refrigeration capacity that they were dependent on.
Right, right. Or you make other choices, and you do not repair your air conditioner, and you ride through a bad section of town with your car window down, for example, and it's just...
Doing development work in Phoenix every August for 10 years, that's not desirable.
No.
My point is that people have lost refrigeration capacity for
Yes.
food preservation and for
Yes.
antibiotics. Because
And for medicines, right.
They just
Right.
can't replace it.
And for these, and for fire protection.
Yeah, and the
That's-
cost of R12 now is sky high.
no. Thank you.
My name is Jane Shaw, and I'm a co-author of a book called Facts Not Fear, and I relied heavily on your work and on Dr. Singer's when we wrote about ozone. But I do want to ask one question. What would have happened, if anything, had we continued to produce CFCs? And would there have been an effect on ozone, either an actual effect on ozone or a calculated effect, I guess? And would there have been any increased thinning over the Antarctic?
Yeah, if you want to put up, well, no, not that one, but one of the Antarctic charts. Chlorine continued to rise in the atmosphere after 1986. No, the one, the Tom's measurements. The chlorine loading continued, but the Antarctic ozone hole remained unchanged after 1986. So that suggests, first guess, that the chlorine loading had nothing to do with it. And in fact, most of the research now suggests that it's really getting these cold temperatures, and what the origin of those cold temperatures is not known. So banning chlorine or changing chlorine may not have anything to do with this at all.
Hi, my name is Mel Affenfeld. I'm a first-timer here. One of my buddies, service buddies, is a retired Air Force tech sergeant. And while R12 may be too good for us, it's not too good for our esteemed leaders. Therefore, Air Force One will continue to use R12. I thought you might have to know that.
Well, you can still use it. You just can't make more of it
They
out of the
can use
bank.
it, but Well, they might get theirs from other countries, like
They might
Mexico.
fly over to Mexico and China and get it.
Steve, I'd like to thank you for bringing up that point about
Yes.
R12-134. I run a shop for nearly 20 years, and I'm having to deal with the practical effects of having to keep people cool in a lot of environments.
Like when they're angry, when they
Well,
see what you have to, what they have to pay?
Cooling is not what it used to be.
Right.
The other two observations about where, my observation over about the last 3 years where it's really had a direct impact. The transportation industry, which is basic, or wheeled transportation, let's call it that way, rubber tires, trucks, cars, that kind of thing. They're already in a marginal profit situation anyway, and the commodities prices, especially in the ag sector, are really getting hammered. I have customers now who used to bring me a $1,000 job and say, fix it and call me when it's done. They bring me a $100 job now and they want a $10 ceiling on it. And they want to know in advance. And needless to say, that drives me to a lot of extravagant measures to try to guarantee something that's going to work. The conversion, not only that, I was told by two engineers, one of them used to work for DuPont when they came up with 134A, and he showed me a copy of the original EMS-DS they came up with, which if none of you know, most of you know what that is. It's a material safety data sheet. And some of the nasty effects of 134A in conjunction with the lubricants that they were forced to use with it makes me very nervous to even be around it, frankly.
Yeah.
So, as far as a practical effect, we now see I'm from Illinois, and in Illinois and in Missouri next to us especially, there's becoming kind of an alliance between regional and local governments and a lot of the businesses who desire for business volume purposes to have the imprimatur of the government on their business so that they get business coming to them. And they pay a series of fees and bribes, more or less, to get the business to come to them and stay away from others. And we're beginning to see in Missouri and in Illinois, I have friends that are shop owners and have been for some time, they're beginning to see a rather major impact in that area. And it's starting to drive the cost of owning a business.
Right.
To the point to where you don't want to hire anybody because you have to become responsible for them totally. And there's no let-out clause or anything like that. You can't mitigate the factor or the effects of it to any reasonable degree.
Right.
Thank you.
Right. Thank you. And none of these increased costs really help the environment.
No, they do not help the environment, and yet they drive the cost of a lot of things that we rely on and consider to be very inexpensive, which were.
Right.
It's taken them to a level where they're basically, you can't afford it.
Right.
Is what it amounts to.
Yeah.
Could someone announce or put up on the screen the URL for Dr. Singer's website?
sepp.org.
Did I understand you to say that China can produce all of this at once?
China and several other countries, India.
If this has
Yeah.
anything to do with the ozone hole or health, why is China doing this? Or is this really, for an entirely different purpose, an attack on the infrastructure of our country?
Your guess is a good one. Please, Steve has got a comment to make.
This information was once upon confidential back in the mid-90s. Since it's many years later, I no longer work for them. The cost for a charged refrigerant of R12 going to your typical sport utility vehicle was about 28 ounces and cost us, our cost, less than $1. At the time of the replacement of 134A and several years after, our cost, our secret cost for 134A was $1 an ounce, times that by 28. So our cost, that used to cost us $1 for your refrigerant charge, let alone everything else we had to do to re-engineer the vehicle, went from $1 to $28. That's R12 134A.
One more question, getting back to the UVB hitting the deck. Did they ever measure the UVB actually hitting the deck at pole station in Antarctica. And has that changed? And I would think it would be much, much less than the UVB hitting the deck at temperate latitudes for simple geometric reasons. Could you discuss any relative, you hear these stories about the three-eared sheep in Patagonia, but even if it all happened, the UVB's got to be much less than those poor sheep down in Texas.
Yeah, of those alleged epidemiological effects, none of them were accompanied by UVB measurements. It was just all an assumption of what the change ought to have been based on these kind of decadal trends. And of course, ozone varies from day to day, meteorological conditions, and you can't really do that. I think there are some limited measurements, but as you said, people in Hawaii understand that when the sun is overhead, it's much stronger. When it has just risen above the horizon, its greatly slanted rays are very weakened. So even if you double it, it's not a significant effect.
Let's not assume that nothing in the world is irreversible. What would it really take to get rid of the Montreal Protocol?
It's actually very simple. The Congress just has to vote to leave the treaty, and they give notice, and 1 year later. What that takes, I'm not sure.
Is there any estimates of other sources of chlorine to the stratosphere?
I've been trying to collect these, so as Willie soon. There are even sources of natural freon that are now being reported, natural halocarbons from volcanoes and volcanic events. But they're not real good documentation on the quantitative amounts of emissions and how that would compare to chlorine loading from CFCs. But there are hints that freon can be naturally made. It may be trivial, but it may be important.
Mount Erebus is running all the time.
Right. But there's no good measurements about what the level is of chlorine, like hydrogen chlorine, and then does that from the volcano get up into the stratosphere, or in some of these volcanic vent measurements I've seen, freon actually measured coming out from them.
Does the ocean contribute?
Absorbs a lot of the man-made freon. In the case of methyl bromide, the ocean contributes. Salt spray, yeah, but how much of that actually gets in the stratosphere is still a question.
I'm not a scientist or anything, but when my air conditioning repairman was checking my air conditioning for leaks, he was holding his little freon probe underneath all the little joints. And when I asked him why I was doing that, he was saying, well, CFCs are like 4 times heavier than air, and you always check underneath to see the leak for the leakage. Could somebody explain to me how that gets to the stratosphere?
Because they're easily carried up by winds. A lot of the winds. You see winds pick up and blow leaves, and leaves are heavy. Yeah. But they do make it up there because you can measure them. You send an aircraft up there and measure them. Yeah. Thank you.